Good morning. My name is Jeff Perri. I'm the President and Chief Operating Officer for ProdataKey. I'm excited to be with you this morning and to talk a little bit about reader technology, something that can be misunderstood in the industry, and certainly if you're new to the industry, is a very important aspect of access control. This is part number 4 of an 8-part series on 101 courses around access control and low voltage. 4 of those series are around introduction to cells, and the other 4 are technical introduction courses. So again, we're excited to be with you and deliver this free content to you to be able to better understand the low voltage industry, how to sell, and some of the technical aspects. I've got 15 years of industry sales and technical installation experience. I've installed thousands of doors myself. So I've been around the industry for a long time and very excited to share some of that knowledge with you when it comes to readers and credentials. When you talk about readers and credentials, there's a lot of technicalities to it. And so I want to jump into some of the technology, but first let's go into a couple of housekeeping items. First of all, this is a live class. Questions are certainly encouraged. So as you have questions, make sure you pop open the chat here in YouTube and chat in your questions. At the end, we'll have a Q&A session where I'll take all of those live questions and I'll be answering those live. So be sure to chat in your questions as you have them. I'll be receiving those and answering for you. But again, this is really to help improve your service and implementation of access control in the industry. So if you're new to access control, this should be a huge value add to you to better understand. It's taking me years to really understand reader technology and the value proposition behind it. And what we're seeing in the industry today is that technology is moving very rapidly. So it can be hard to keep up with, and I'll share a little bit about where the industry's been, where it's at today, and where we perceive that it's going to help give some understanding to that. So if we look at this slide, I want to talk about the different types of readers. The first type of reader is a standard proximity reader. I'm going to show you just a couple of these. Let me just bring in a couple of standard prox readers. So you'll see a couple of different flavors of prox readers. If you've been around the industry at all, you've seen these different types of readers. But again, they can come in many different mounting options. But it's just a standard prox reader, and we'll talk a little bit more about the technology behind the prox reader here in just a bit. The next one that I want to show you is the keypad reader. So let me bring in a couple of keypad readers. This one right here happens to have a touch screen on it. And this one here has buttons that allow you to physically press those buttons versus a touch screen. And there are many different variations of this. But these 2 types of readers are a reader and a keypad combo. So that's another type of reader that we'll be talking a little bit about. The next one, I don't have a demo of this here, but it's a QR or barcode style reader. So if you're going into an arena or an area that uses membership management and you have a little card or credential or a ticket stub that has a barcode on it, this is something that we've seen used many times, where you can put a QR or a barcode reader at the door and allows them to use their standard ticket or maybe a membership that they have that has a barcode on it and scan that under that reader, and then that transfers to a Wiegand output communicating to the controller. So that's a very valuable method of access control, especially if you're working with places, again, that utilize tickets or membership management style platforms. Another technology I want to talk about is data on card. This is something that has been misunderstood in the industry for a long time. There are many that do understand data on card, and there are some value propositions behind a data on card platform. And essentially what that is that my card or my credential that I have is what holds all of the data. So if I come in to the front door of a building and I scan at that reader, that particular reader might be a master reader. And so that particular reader is reading my credentials off the card and granting me access to the building based on my access rights that are held on the card, not within the access control system. So it's really the card telling the system that I have access, not the system reading the card number and saying, yes, he does or does not have access to that particular door. So some of the benefits to a data on card scenario are this, what many people, they call a wireless solution, but really it's wireless in that you're carrying the physical credentials on you all the time that has all the information. I've referred to this in the past as security through obscurity, because there are some real security flaws when you talk about data on card. But again, there are some benefits. So you have to weigh the benefit and the security propositions that are there. Some of the security through obscurity portions of this really come into play when you've got your data on card, you scan at a master reader, allows you into the building. Well, now I can scan at any other reader in the building that is a slave reader, and again, those slave readers know that I have access to that particular door because the card or the credential is telling that reader that I have access. Again, that decision is not being made by the access control platform. So what ends up happening is if I go and delete somebody's access to a particular door and they go scan at one of those doors that is a slave door, those slave doors will continue to grant them access to those particular doors. And that's why I call it security through obscurity, because a lot of times the user, which I'd call the employee or the tenant, doesn't understand the technology that's being used. So most of the time they're going to go and scan at one of the master readers, which then reads all of the audit trail of places that they've been that's been written to the card, and then uploads the new access rights. So again, just to reiterate, data on card, if I come to a master reader, lets me in. I go to slave readers, lets me in based on my rights or the schedule that's built onto the physical card itself. I can get around anywhere in the building until those credentials expire, or I go back to a master reader and it deletes my credential rights. So those credential rights can, one, expire, so you can have them expire daily, or you scan at a master reader and then it uploads my new credential rights. So that's why I call it security through obscurity, because sometimes they are significantly less secure than a standard access control platform with a standard reader. But I think it's very important to see that there could be some value propositions to data on card, because it kind of gives you this wireless feel. There's less infrastructure behind it in most cases. So again, you have to weigh the benefits versus the security of that. The next one I want to talk about, and I'll show you a couple of these readers, is the biometric side of things. So this is a facial scan biometric. You're going to see another like a fingerprint biometric. I really like biometric technology. I can't say for sure where the biometric technology is going to go. I'm going to share some of my thoughts on where I believe that it's going and where a lot of our technology is being developed around biometrics. So if you look at a Bluetooth reader or a mobile credential, what I see in biometrics is this vast movement towards mobile first technology. And so as you're utilizing mobile first technology, we start to recognize that the watch that I wear, the phone that I have, all has biometric technology built into it. So putting a piece of biometric hardware on the door or on the wall next to the door is going to be less and less viable as we move into the future, because I already own the biometrics, and my devices, the smarter that they become, the more they know who I am as an individual and can grant or deny me access based on those particular rights. So I believe that as we look at biometrics, it's going to move further and further from a physical unit that's on a door or a wall and move more and more to the mobile first platform that's being built today and the technology that's encompassed there, because the technology is already there. It really is just mapping those two technologies together. And there's a lot more behind that. I'll touch on it just a little bit more as we get into this. Another technology I want to talk about, and this isn't necessarily much of a technology, rather it's some different data points that are put together, is PIV. PIV technology is really built around government credentials. So if I've got a government CAT card, it's using a PIV style reader to read that. We're going to talk a little bit about the HID I-class reader, that some of those readers can read the government CAT cards and adhere to PIV style technology. So again, if you're installing in a government institution where they're using the government credential or government CAT cards, you'll want to look into PIV technology. That's something that is incorporated into the reader and has to be well understood as you get into utilizing that technology. There are some access control platforms that are certified with PIV certification, and then there are others that just can handle that type of credential. The last one I want to talk about is mobile credentials. When we talk mobile credentials, your two things that come to your mind are BLE or Bluetooth and NFC. I look at these two different technologies very similar to how we looked at the Blu-ray disc back in the day. I say back in the day, it really hasn't been that long, but a Blu-ray disc, a CD, and back when I was growing up, I don't know if you remember, but the big compact, they call it a compact disc or a laser disc. So, you know, those started coming out. And the question was the DVD going to win, or was this laser disc going to be really the unit that moved into the future? And as we saw, DVD won hands down, and then obviously it moved into Blu-ray technology. But I look at Bluetooth and NFC very similar. Most phones are capable of utilizing both technologies. BLE obviously utilizes the Bluetooth technology that's built onto your phone. NFC obviously uses your near-field communication communicator that's on your phone. So when I go and do a payment at a store using Apple Pay or Google Pay or whatever it may be, it's utilizing that NFC technology to communicate that to the reader. So it's really unique when you look at Bluetooth or NFC technology. We feel like the Bluetooth technology, it's already got a lot of traction, but you saw a lot of different companies dabbling in both, and we're seeing the Bluetooth technology really winning outright. Although one thing that I found significant about NFC technology is if somebody wants to utilize NFC and you use an HID I-class reader, most of the HID I-class readers will read the NFC off of your phone. And that credential number, which is again just your NFC number coming off your phone, is a consistent number that will read into an HID I-class reader. I wouldn't necessarily ever suggest installing access control that way. It doesn't really make a ton of sense to me. But if you wanted to dabble in NFC technology, you could. I think as you get down the road, it's going to be harder and harder to support that. So it's probably something that you don't want to mess with. But it's an interesting piece of technology to recognize that an HID I-class reader will read the NFC off of your phone. So let's talk about the different types of readers. We already talked about keypad readers and standard prox readers, but I want to talk about the different mountable mounting options for readers. And the first one we're going to talk about is your mullion style reader. These are typically elongated, skinnier readers. What's unique about these is they're slim and they're attractive in their design. But they're made to be mounted much closer to the door. So if you're not mounting on a wall, typically you would pick up a mullion style reader, and that mullion style reader would be mounted right on the mullion, or that slender part of the door next to the door. Again, allows you to get it closer to the door, typically looks really slick, and has a really good form and function to it. So I'm a huge fan of a mullion style reader. One thing that you'll find about utilizing mullion is that you decrease the distance of your read range. And we'll talk about read range here shortly. But again, mullion mounted controllers are one option for installing access control. One of the things that I've seen, which in my opinion is one of the biggest faux pas in the industry, is I've seen where integrators will take a metal plate and put it over a single gang box that might be on a wall and mount a mullion style reader to it. Now there might be some reasons to do that. I can't think of any off the top of my head. But if you're utilizing a mullion reader, use it for the mullion of the door. But again, you may look at options and there may be a need to do it that specific way. If you're mounting to a single gang box that's in a wall, then you would typically utilize a single gang style reader. It's going to be a little bit wider. Again, a single gang box is the same size box that a light switch is mounted to. And these readers are made to mount to those same mounting holes. So if you're in a new construction environment, what I would typically suggest is mounting a single gang box, if you want it in the wall, mount it close to the door, and then in turn, run your access control wire or your reader wire down into that box so that it's stubbed out ready to go. When the sheet rockers come in, they're going to rock around your box, and then when you come in to mount the reader, it's going to be stubbed out, ready to go for you. So that's something to really consider. I've seen many applications. I'm a huge fan of doing readers that way in a lot of different environments. Does it make sense for all? No. Mullion style readers work fantastically, and it's something to really consider when you're looking at a mullion or a single gang mounted style reader. Another one that's becoming more and more popular as we see more offices moving to glass are glass-mounted readers. We happen to be a partner with Assa Abloy. They're a Aperio line, so I understand the Aperio technology really well. Essentially, with this type of reader, you've got the glass-looking reader that you can see on the left side. On the very left, you're going to notice, let me just use my pointer and I can show you. This is the hub right here. And then you can see this is an access control controller with a reader and keypad built into it. And then this one right here is a reader only. So regardless of which option you use, you will need to install one of those hubs, and then you can mount one of those readers to the glass. So if you need reader only and you're not looking for door functionality built into it, you'd mount the hub, plug the hub into the network, and then you would take the reader, and it has a glass mount kit that comes with it. You'd mount it to the glass, you're up and running. If you want a keypad reader all-in-one, then you can purchase the Assa Abloy Aperio lock set that comes with a reader and the keypad built into it, and it also is the locking hardware. So I want to show you a quick video on what this locking hardware looks like on a glass door. So you'll see that it's got the locking hardware built behind it. The reader and keypad is on the front. It's really, really a clean look. And it's communicating directly to the hub. These particular readers are rated at a 3-year battery life. So if on average use, you're going to get about 3 years of battery. So it's a fantastic option when you've got all glass walls, or maybe you've got an entry of an office space and you want to put the reader on the glass closer to the door, but it's an all glass front. So at that point, you can mount your reader to the door, to the glass that's next to the door, and then you can mount your locking hardware to the physical glass portion of that, and it just allows you to place the reader closer to the door. Otherwise, on the inside of an office where you've got the swinging glass doors without a mullion, the Asa Abloy Aperio lock set would be a better fit there. But glass mounted, fantastic solution. I've used them many times. Another one that I want to look at is pedestal mounted readers. Typically it's going to be your single gang reader, but it doesn't have to be single gang. All of these readers can mount to a pedestal in one form or another, but many pedestals have a mounting kit, or an enclosure typically has a mounting kit for a single gang style reader. So just make sure if you're mounting it to a pedestal outside or near a building that you're looking at what the mounting options are for that particular pedestal as you're choosing the type of reader that you're going to be mounting there. All right, now I want to talk about a little bit more about the technology behind readers themselves. So I want to talk about from the credential to the reader, and then next we'll talk about from the reader to the door controller. What's unique here is when you talk about the different types of technology behind the credential, the reader itself, and the controller, most of us just utilize all of that verbiage or all that communication seamlessly. But in reality, all of that technology or the different aspects of that technology are very separated from each other. So if you look at this slide, you see that there's standard procs, there's I-class CE and SE that we'll talk about here in just a little bit. There's proprietary readers that have a proprietary communication structure. There's a Bluetooth style reader that we talked about, and then NFC. So again, that is going to have a lot of impact on the communication from the card to the reader, and then again from the reader to the controller itself. So let's talk about a couple of these as we talk about bit formats. So first, one thing that's really misunderstood about bit formats is the bit format has to do with the credential itself. This isn't a structure of the reader, although some readers are limited in the number of bits that they can read. But typically, most readers can read almost any bit length. And then they're just taking that bit structure and passing it through to the physical controller itself. So again, it's the credential or the card, the fob, the bracelet, whatever you're utilizing that is typically handling the different bit structure. And I'm going to break that bit structure down. But again, the reader itself, in most cases, is just a pass-through style reader. I hear a lot of people say, oh, I've got a basic 26-bit Wiegand reader. Well, that's not typically the case. You have a Wiegand reader in most cases. And that Wiegand reader can read 24, 26, 32, 35, 37, and so on. So again, your reader is typically a pass-through device that's reading the credential and then passing the bits that your card has back to the controller itself. What's interesting about the bit structure on the card itself is that the bit structure has a lot to do with your physical card numbers. So if you look at a 26-bit credential, you're going to notice that you can have 255 different facility codes, and you can have 6,535 different card numbers. Now, if I've got card number 1 all the way through card number 65,535, I can have that same structure in all 255 different facility codes. So essentially, it's giving me approximately 16 million different card numbers. Now, what we're seeing that's unique in the industry is that people can now clone cards. If you go on YouTube, you can search the technology. You can buy these types of devices on Amazon. You can now go to some stores where they've got kiosks, and you can just read your card. It'll read the information and spit out a new one for $25. So there's a lot that can be done in duplicating standard prox credentials. I'm going to talk about more secure credentials here in just a little bit. But one thing that I want to show you is that as you increase the bit rate, a lot of people think, oh, well, I'm just going to increase the bit rate and that increases my security. Well, that's sort of true, but in reality, there's not a ton of truth to that. Because if I get to 37 bits, you're going to notice that now it transfers. I've got 65,535 different facility codes with a possibility of 500,000 different card numbers on each one of those sets. So it's in essence, it's giving me approximately 32 billion different card numbers. So when a lot of people think of security, they think, oh, well, now because I've got so many cards, they're not going to duplicate. And in many cases, yes, that's the truth. It's very difficult to duplicate. And even if you use one facility code with 500,000 different card numbers, there's not many, a good majority of the companies that are installing access control. I think this latest stat was about 80% of access control is 8 doors or less. Or 10 doors or less, somewhere right in there. So if you're looking at that statistic, those types of companies typically don't have 500,000 employees. So duplicating those cards doesn't happen very often, but could they take their card and get it duplicated on a standard prox? The answer is yes. So you want to be very cautious, but understand the likelihood of duplicating cards is much less likely with a 37-bit versus utilizing a 26-bit credential, because you can see how that bit structure duplicates the number of cards. Another thing I want to point out is that the 26-bit structure that's been developed in the industry is an industry-wide standard. So, most of the reader technology that's been developed is really well known by HID or HID Global. They're a fantastic company. They're an OEM partner of ours. But they don't own the 26-bit Wiegand format. That's a widely owned platform. If you look at 35-bit or 37-bit, they own a lot of the technology that's behind the 35 and 37-bit structure. So if you look at HID's Corporate 1000, their Corporate 1000 cards in the 35-bit structure is a proprietary platform for them. And the reason I want to bring this up is because it plays very heavy into facility codes. Most people anticipated, and I illustrated right here, how adding facility codes can really remove the likelihood of duplicating a credential. But in reality, what happens, what's happened is facility codes were originally developed so that access control integrators could have more proprietary style cards and sell them to an end user. For instance, when I first got into access control, I remember going to one of my clients and saying, hey, I'd love to sell you your credentials. And credentials is a big business. And so I approached them and I started selling them a couple of boxes of credentials. She immediately came back to me and said, hey, for some reason your box of credentials doesn't work. I found out that the other organization that installed the access control had a facility code built into the system or programmed into the system that didn't allow my cards to work because it was only structured to fit their facility code. So in other words, if I couldn't order cards with that facility code, which I could not, this was a large corporation that integrated the platform, so they owned that particular facility code through the card manufacturer. So I went to the card manufacturer, I said, hey, I need to get this card and this facility code. They said, sorry, that's actually owned by this large corporate client of ours, so you can't order credentials that way. So it was initially a way to keep a more proprietary feel for the integrator with their customer, but you can see the security aspects behind facility codes as well, in less likelihood of duplicating credentials and those types of things. So you'll also see that with the Corporate 1000 cards. Corporate 1000 cards allow HID in this case to help you better manage your corporate customers. But you have to be very intertwined with HID when you order those cards, because you're ordering them specifically for a customer. You're not just going to distribution, picking up a box of cards and taking them to the end user. So again, understanding facility codes, card numbers, the bit structure is all extremely important, and again, has to do with the card, not necessarily the reader, where the reader becomes more of a pass-through device taking that credential. The last thing that I'd point out here is that you can't take a card with a different style of technology and scan it at a standard prox reader and expect it to work. So as you're going out bidding or installing projects, you do want to make sure that you look at the types of readers and or credentials that the customer has in place. And if you're changing out the access control system, making sure that you take one of their readers, connect it to the access control system, or know what technology is being used so you can determine the capability between the credential, the reader, and the access control system. Nothing is worse than getting into an installation and realizing that the readers won't work on the door controllers that you purchased, or the credentials that you're ordering and supplying to the customer, you don't have the ability to get those. And so now you're having to reorder all new credentials, or you're having to install all new readers so that they will work with the credentials that you have. So it's very important to understand the technology all the way from the credential to the reader and the controller, so you make sure you don't get in a bad position. So let's I just want to touch on this really quick. Card format and facility codes, we talked about those. These are all read in parity or bits. And what you're going to notice at the top here is that your first section of your card number is going to be your facility code, or 8 bits. And this is a standard 26-bit, so it reads a little bit different with the different types of bit rates or bit formats. But you'll find that typically your first bit, your leading bit, is a parity bit being read by the reader. And then you've got your facility code, and then you've got your card number, which is then another 16 bits. And then you've got your trailing bit, which is typically an odd number. So it starts and ends as a bookends, and lets the controller or the platform know that you've started and ended that particular card number. So again, when you're looking at the card number on your card itself, not all cards have the facility code on the card itself. And again, that can be something that's very difficult, because I may say, oh, I'm going to come and install access control for you, and let me just look at your card and see what facility code you have. Well, that's not the case on every card. Most cards just have the physical card number on the outside of the card itself. And when it's scanned at a reader, it's just reading that facility code and the card number. So unless you have the box, on the end of the box is where you're going to read and find the facility code. So just make sure that you either have the box or you have access to the facility code if you're wanting to sell credentials to somebody that is utilizing a facility code, or look at a system and see if it requires a facility code, or in most cases you can add an additional facility code to an access control platform so you can utilize multiple facility codes. But understanding how this bit structure comes together is something that I think is really important. Now let's look at from the reader to the controller. Okay, there are a couple of different communication methods. One of them is Weekend, which is probably one of the most widely known access control communications from the reader to the controller. It's very heavily used today. There's a new standard called OSDP that we'll talk about. There's also clock and data and 485 and 232 communication. Now, these have a lot to do with the connectivity, again, from the reader to the physical controller itself. So a standard Weekend typically is going to be 4 main wires. There are additional wires on a Weekend reader, but the 4 main wires are a red and a black for power, and then also a data 1 and a data 0. Now, what's interesting is when you look at reading the card at the credential, it's reading those bits, right, and the parity. So you're beginning and ending your facility code and your physical card number, and it's sending that through the controller. And then what it's doing is it's oscillating the data 1 and data 0 between data 1 and ground and data 0 and ground. And that oscillation is creating these ones and zeros, just like we've seen in the computers. And it takes that data and tells the controller, this is the card number that was just read, and the controller is what's deciphering that. Again, the communication it's no different than speaking English or Spanish or another language. This is just one language that the reader is using to communicate to the controller, and it's a weakened communication. Now, one thing that people have been very skeptical about is that with weakened communication, somebody could strip back those wires, put little probes on it and read the communication or the card number that's coming from the reader. We'll talk a little bit more about that. So that's why OSDP came out. Weakened is something that's, again, still very strong in the industry. I wouldn't suggest just throwing it all in the trash and moving to OSDP, though OSDP, there are some value propositions to OSDP. So if you look at an OSDP communication, it really is more of a digital versus analog communication. So though a weakened reader, again, is just switching those bits, sending the information, that's being done with just a standard connection. I look at OSDP more like a digital communication, because now communication doesn't just go from the reader to the controller. The controller can now communicate back to the reader. So on a standard weakened reader, you would typically have an additional wire to trigger the red or the green light to trigger when the lock was unlocked or locked. With an OSDP style reader, I've got two-way communication. So now the OSDP communication can communicate back to the reader and tell it to turn its light on or off, or piezo on, piezo off, that type of thing. So that's why I look at it more of as a digital communication versus a weakened. I look at more of it as an analog communication structure. Another thing that OSDP clouts, and the main reason behind OSDP, is it has an encryption from the card to the reader and from the reader to the controller itself. So if you're looking at home running access control, in other words, I've got a 2 or 4 or 8 door controller in a security closet, and I'm utilizing standard weakened readers, the theory or the concept here is that if I've got one of these wires that happens to be running through a public hallway back to a security closet, which there are some of those in this building here, that then I could pop up a ceiling tile or get access to those wires. I could strip them back. I could put a probe on them if it's standard weakened, and I could read or inject card numbers and surpass a door. Now, it's not something that's just a 2-second deal. So, when you look at security, you have to look at all aspects of security. How much time is it going to take to thwart that? Are there wires running through public areas? Those types of things. OSDP, again, is an encrypted communication from the reader to the controller itself. So, in essence, if you were to strip that back and tie onto those wires, the likelihood of you decrypting that encrypted information is much less likely than a weakened reader. Now, one of the issues, I shouldn't say issue, but anomalies here that I see is more and more controller types are edge style controllers. So if I've got an edge style controller that's mounted on the secure side of the door, I've got my wire running down the mullion of the door inside the metal frame and coming out to the reader, somebody's going to have to unscrew that reader or break it off. Then they're going to have to strip that wire back and probe and inject reads onto it in order to get into it. Now, they wouldn't be able to do that, or it's a lot less likely on an OSDP encrypted communication. But again, it's something to think about when you're utilizing an edge device. The likelihood of somebody breaking into that is much less. But again, if it's a much more secure facility, you might look at utilizing OSDP. I know there are some integrators out there, and again, I am a proponent of this. I think that it's important that just do everything OSDP, fully encrypted readers, and I think that's great. But understand the use case of the end user and how they're using it. I would attribute a good portion of access control, not all, but a good portion of access control is there's a convenience factor to it. So a lot of times people will take security and convenience and mix them, and sometimes you really have to identify what that is. And I'm just throwing out all scenarios here. There's a way that I would do it, but I want to make sure that you make that decision for yourself based on the different types of technology that are available. Now, clock and data, that's not as widely used today. 45 and 232 aren't as widely used today. But clock and data was something that was valuable, especially if you use the mag stripes on a card. Again, clock and data is the communication from the reader to the controller. That's information that would be passed through. Those would also be considered less secure. 45, I guess you could create a secure communication. OSDP utilizes a 45 style connection between the reader and the controller. But just so you know, these are the standards. The two biggest standards in the industry are Wiegand is number one. OSDP is now making a huge, making up a ton of ground and is becoming a leader out there. Clock and data, 45, 232 communication aren't as widely used in the industry. Now I want to talk about I-class credentials. And I'm talking about HID I-class because I understand the I-class really well. If you look at Indala and some of the other technologies that are out there, there are some other proprietary security technologies that create security between the credential and the actual reader itself. So this, when you look at I-class and some of the other security technologies, it's not the security between the reader and the controller. This falls into the same arena of the security between the credential and the reader itself. What's interesting about I-class is it was originally developed because of this concept of duplicating cards and increasing security. So they wanted to solve that. They originally came out with I-class CE. So if you take a reader off the wall and it's an older I-class reader, it may say I-class CE. That was the first generation I-class credential or reader out there. One of the issues that they ran into with the CE was that the encryption key, which was the same with every single reader that they had, was the same on every single reader. So the obvious issue with that is somebody took one of the readers, completely took it apart, found the security chip, they delaminated the chip, put some probes on it, and found out what that key was, and then they made that key public. So now all of a sudden, every I-class CE reader on the planet has been compromised, and they're stating that there's not as much security between the I-class first generation CE stuff. But if you look online, you can't find any I-class CE. Pretty much you can't find information on it anywhere. But you can, I'm not aware of you even being able to buy the CE. I just think it's important to note this, because if you get to a project where they're utilizing I-class, knowing that there's CE and SE, I think is very, very important. Now, SE is the latest technology. It's their second generation technology. And now what they've done is created an encryption key for each one of the sites or facilities that you go to. So those encryption keys are different. The downside to that is you have to order these for specific projects. You can't just go buy a SE reader, put it on a project, and then buy credentials for it. Typically, you've got to have a little bit more hand-holding with HID when utilizing the second generation SE because, again, it's not the same encryption key between all the readers. One thing that you're going to find is that with encrypted credentials and encrypted readers, there's a longer read time as well. So don't install an I-class reader or another encrypted style reader, hold the credential up to it, and then expect it to be instant like you will on a prox reader. Because a prox reader, what it's doing, and I'll show you a little bit more behind this technology, is just reading that credential, passing it through, authorizing or not authorizing that credential, and with an encrypted, it's actually sending the encryption key to the credential. The credential is encapsulating its card number in that encryption and sending it back to the reader. So there's two forms of communication that are happening there versus just the one-way communication to the reader from the credential. So very important when you look at encrypted. And again, I just pointed out the I-class, wanted to talk about the first and second generation, but just know there are other manufacturers out there of encrypted credentials and encrypted readers. Okay, so now let's look a little bit more behind OSDP. I talked a little bit about this, so we're not going to spend a ton of time. Again, OSDP is from the reader to the controller. Has nothing to do with the card to the reader. But the reason that I wanted to show this was because you could, in essence, you can utilize an I-class SE reader with OSDP technology, and now you've got I-class technology that's encrypting from the credential to the reader, and then you've got OSDP technology that's encrypting from the reader back to the controller. So if you need an encrypted, very secure communication all the way through the process, then you would want to use something like an I-class SE with OSDP communication to go from the credential to the reader back to the controller so that you've got security all the way through that. So let me just show you some of the internal guts and the reason behind the different sizes of readers and credentials. If you look at the physical credential here, you're going to notice that it has a coil in it and a couple of chips, okay? Now those chips, one of them is a microchip, the other one handles the power in the coil portion of this, or actually, sorry, this is a dual style credential, so it reads two different types of technology. So you'll see the two different types of chips. Now, what this is doing is it acts very similar to an EMP. So for those of you that understand EMPs, very similar to what you see in the movies, you know, somebody detonates a bomb or something large in an area, and it creates this EMP and takes out all of the electronic devices that are out there, okay? So this is doing something on a very similar scale, or, you know, similar to like a microwave, where it's sending EMP pulses to this, what I call a passive card. So if you look at the reader here, you see that there's a coil inside of the reader itself. So both of these readers, the small one and the large one, have coils built into them as well. So on a passive reader technology, I take the credential, I hold it close to the reader. As soon as it gets close enough, that reader is sending out an EMP pulse. It powers up the reader through that coil, very similar to an electric motor. And as soon as it powers up, that credential is then chirping out its number. And the reader is actively sitting there listening for the physical number. And again, that's on a standard Prox card and standard Prox reader. So if you've got a 26-bit Wiegand card and a standard Wiegand reader, like you see here, you hold that card up to them and it's going to chirp the number out as soon as you get it close enough. The difference between these different, obviously you've got one that's a mullion style reader, and then you've got a long range reader. This is actually much larger than a single gang, but the technology is the same. Whether you go from mullion style to single gang to this one that's wall mountable and quite large. I've even seen companies cut out sheetrock and mount this behind the sheetrock because it will read long enough. It all has to do with read range. It's got larger coils in it and can read your credential from a further distance. So if you look at a small key fob plays a factor in the distance. So if you've got a key fob and a mullion style reader, my distance is going to be substantially smaller than if I utilize a card that's got a larger coil and a larger reader, or even a larger card with a smaller reader. So the combination of those plays every part in the distance you're going to get in your read range. Now, the last thing I want to touch on here is going to be passive versus active credentials. This doesn't have to do much with the reader itself, but if I'm going into a parking garage and I want really long read range, I probably won't utilize the long-range reader here. And I would if I'm going to mount it to a pedestal, because then I can just hold my card out the window. And you see that, you see that in videos and in movies and that type of thing. But if I want to give somebody the experience where they're driving up to a gate and the gate just automatically opens, I'm not taking my credential out. I'm going to utilize an active credential versus a passive credential. An active credential essentially is a powered credential, has a battery built into it. And you're going to see that a lot of those are mounted up behind a visor. They could also be mounted to a license plate. I've seen license plate active key tags. But in essence, an active key tag has a much further range, or typically is communicating on a UHF communication to a reader. So if I'm using a parking reader or parking garage style reader where I want to pull in, opens up and lets me in, you're typically going to use an active reader versus a passive. Now they're making long strides with passive credentials that can give you some of that distance, but still I'm not aware of many passive cards or credentials that will have the same distance as an active credential with a long-range UHF style reader. And there are many different manufacturers of those, both credentials and readers. Okay, so let's talk a little bit about wiring methods as we get closer to the end here. You're going to find that different types of readers have different wiring methods. Most of the readers out there have pigtails on them. So if you look at this reader here on the screen, wires are potted directly into the reader and coming off of it. And you're going to bring your access control wires out of the wall. You're going to pigtail them on with bean clips, and you're going to be up and running, ready to go. Now, the other style is going to be terminal strips. There are some readers out there that have terminal strips, and there are different reasons. I know many people that say, you know what, I only use terminal style readers, and many others that only use pig style readers. The value behind utilizing terminal strips, you've got one wire coming out of the wall, you're going to terminate those directly in. You're not having to mess with bean clips. So if you've got a small hole in the wall or in the mullion of a door, you're not having to worry about feeding those through. It's typically not an issue because you just tape those up and feed them through if you're utilizing the pigtail style. But again, not something to be super concerned about as you're looking at. I just wanted to show you the different type of wiring methods that you might see out there. Now, I want to talk a little bit about the connections. There are a couple other connections we talked about. On a standard prox reader, there's a positive, negative, data 1, data 0. And again, that data 1 and 0 is toggling with my negative. So the one last thing I talk about in that connection is you want to make sure that you're sharing the same power supply with ground as you have on your controller that has your data 1 and data 0 connected to it. If you don't, then you're going to find that data 1 and 0 is trying to toggle with your ground, but doesn't have the capability of doing so because it's got a separate power supply. So make sure that whatever you're powering your controller with or your readers is also what's powering the ports or the controller that is toggling the 1s and 0s. But you're also going to find a couple other wires. One of those is a tamper. So if that reader gets knocked off the wall, it's got a tamper. And that can be a physical switch that's touching the wall or optical. One of the issues you can run in with optical is if the reader's not mounted solid to the wall or it's mounted to brick where you've got light showing through. As soon as the daylight comes up, it could shine through there and trip an optical sensor. So we've seen that. You can fix that with a little bit of caulking or put, if you're not as concerned about the tamper, maybe it's at a clubhouse or something like that, you could put a piece of tape over that. I don't ever suggest doing that, but typically caulking around that so it's not getting light so that you can continue to utilize that optical sensor if that's what it's utilizing. Another one is for the piezo. If you're in an instance where you have a pool gate or an area that you want to know if a reader gets knocked off the wall, or if a door gets propped open and left open for a certain amount of time, you want a piezo going off, you typically don't have to add an additional piezo to the system. The reader has a piezo on the back of most readers, and you can trigger that from the controller itself. So if my door gets open and propped open for 20 minutes, that piezo can go off and then I know that that door's been propped open, and then the hope is that somebody comes and closes that. The last one is a light trigger. So on a standard Prox reader, you're going to find that it's got a light trigger on there, and that light trigger will trigger the light to stay green anytime that door is unlocked. And then as soon as the door locks back up, the light goes back to red. So again, those are a couple of different options that you'll see on different types of readers, or for a majority of the readers that are out there. Now, the last thing I want to talk about before we close up here and get to the Q&A is controller versus controller reader. Now, there's been a lot of these controller readers come onto the market. And again, I don't want to push on you my opinion, but I want to give you the pros and cons of these types of things. Now, a standard reader, obviously there's only so much that you can do with it, especially if it's OSDP and you're utilizing iClass or another security method, then it's going to be encrypted all the way back to the controller itself. But what we're seeing is a couple of different companies coming out with reader controllers. In other words, the controller itself is built into the reader itself. Now, there are some integrators out there that say, hey, there's a lot more convenience. I can pull the wire down, I plug it in. But one thing to consider is that if you knock that reader off the wall, now you've exposed all of your wires, including your locking wires to that. I've heard many say, well, yeah, but it's got a tamper. And then the question is, well, how fast are you going to respond to the tamper before they take that wire and just cut it if it's a maglock, and instantly that door's open, right? So it makes a much quicker access if you're utilizing that type of controller. Another thing to consider is that you're still pulling wires, okay? Let me share with you a quick instance. When I first got into access control, I had a gal call me. She said, hey, look, I'm not using the access control system that you guys were proposing to install, but I had this door that got locked. We got locked out of the security closet. Can you come help us? I went out there. It had a mullion style reader. I unscrewed the mullion style reader, took it off the wall, and I found that they ran the locking wire through the single gang can and over to the lock, okay? Well, having a controller and reader built into one is the exact same concept. All I did was take that wire out, I stripped it back, I took my drill battery, popped it onto the strike wire, and I had the door open within seconds for her. Obviously, she was super excited. We removed that wire out of there and re-ran it. But just understand that if you're using a controller that's built in, not only can they rip that off, they get access to your network because they've got the RJ45 jack now, but they also have access to the physical locking wires that are there. But again, you're also still pulling wires. So now you've got to pull your locking wires to that reader. You've got to pull your DPS and REX and whatever else to that reader, where you could just as easily pull them up to a controller or something like that. So typically, you're going to find with a reader controller built into one that there's less options, less functionality, that in many cases it makes sense just to pull it to a controller. You've got much more functionality, many more options to your dealer, to your end user. And in my opinion, it's significantly more secure and less vandal resistant, or less likely to be vandalized. So I want to talk just a little bit about a couple of the upcoming courses. We've got Knowledge and Demoing, which is our next Access Control 101 class. That's on May 12th at 10 a.m. And then our next technical class is going to be Locking Hardware. Again, very similar to this. It's going to be a 101 style class on locking hardware. Really excited to show that to you. So now let's jump into the Q&A. It looks like we've got one question here. How are the Apereo readers powered? Fantastic question. They're powered by batteries. Again, they tout a 3.5-year battery life. Also, if you utilize some of the other Apereo technology, this is a lock that has batteries built into the back of it. Very quick to install. It's about 20-minute install on a door, certainly under an hour depending on your skill level. But that's also battery powered. So the Apereo locks, the readers, And all of these things that I've showed you are all battery powered, and again, tout about a 3.5 year battery life. Next is the wiring any different for Bluetooth readers connecting to a cloud node? What I want to do really quick is just show you a quick video on Bluetooth credentials, and then I'm going to show you a little bit more about the Bluetooth technology and why that's so important.
Having a secure office doesn't have to be inconvenient. Touch by ProdataKey is the easiest and most secure Bluetooth access system. Your phone acts as your credentials without having to leave your pocket. Other systems are less secure because the readers can't distinguish between credentials inside or outside the office. But with Touch's inside-out technology, a phone inside can't accidentally be used to let someone in. Installation is very simple, since it uses Bluetooth and mobile app for enrollment. And integration to existing access control is seamless, since Touch works with RFID technology. Touch also comes with an easy-to-use app that allows users to grant access remotely. But the best feature of the app is that it has made adding new users easy. Simply issue mobile credentials directly from ProdataKey. Touch by ProdataKey. Finally, a Bluetooth reader with real intent.
Now there's a lot of information behind Bluetooth readers, Bluetooth credentials, and those types of things that I think is really important. And so that's why I love this question, because I'm going to go a little bit deeper than what I typically would with some of the other questions, because I didn't take the time to talk about Bluetooth as much as I think we needed to. And when we talk about where the industry is going, again, we believe that Bluetooth technology, or BLE, Bluetooth Low Energy, is the direction that the industry is going. And we're seeing a lot of that tech out there right now. A couple of the differences that you'll see in Bluetooth technology is that you really have to determine intent, right? And the reason that I wanted to show you this video, and I know that it's branded with our stuff, but one thing that we really clout is the intent. If I approach that door, how does the door or the Bluetooth reader know that I want to go through it? And that's the issue that everybody's been trying to solve for a long time. And so you'll find that most Bluetooth technology in the industry is all focused around how close do I get to the reader itself with my phone. And so if I've got my phone here and I set it up for 2 feet, then that means I need to get within 2 feet of that reader. If I set it to 20 feet, now if I'm within 20 feet. The issue is with that type of technology utilizing Bluetooth, if I'm walking down a hallway, now all of a sudden it doesn't really know my intent other than if I'm just close to the reader or not. That's the intent. So I could walk next to a bunch of doors, and all of a sudden all those doors could open up. So that's the first thing that you need to look at, is intent, and how does the customer want to determine intent at the door. The next one is we don't see a separation with most technologies on the credential side. So when you're utilizing a lot of technology out there on the Bluetooth side, you're seeing that most of the manufacturers are still selling credentials. So now that credential is merely a number that's in the cloud, it's loaded onto an app on your phone, and there's not a ton of substance behind that physical credential. So they're still selling the credential to you as the dealer. You in turn are then selling that credential to the customer. And so with this type of reader, you're going to find that the two main things that we looked to resolve were intent and the credential cost. And so what we did is we traded the cost of credentials for a small licensing per reader cost. So now if I've got 1,000 credentials, now all of a sudden I'm not paying $3,000, $4,000, $5,000 for those credentials. I've just got a small per reader license fee. And so we really look to manage that a little bit differently. Another thing that you're going to find is on the intent side is that you could not also identify whether somebody was inside or outside of the door. Now we call our reader touch because you touch it, authenticates with your phone, and unlocks the door. That's the intent. There are a couple other readers out there that you touch the reader and it again reads your phone, authenticates with it, and then lets you in. But that can't be the sole purpose, because if I happen to be inside, like you saw on this video, chatting with somebody, in that type of technology, you could still touch the reader and it would unlock the door. If I happen to be at a reception desk and you had the distance turned up, somebody could touch that and authenticate at the door. So really, most of the Bluetooth technology out there today is focusing only on distance, with some of them focusing on some intent of touching the reader or utilizing a gesture. I'm not a huge fan of utilizing a gesture or touch only, and the reason behind the gesture side is I still have to pull my phone out of the pocket. So for us, it was, how do you identify intent, cost, and security? And also I have the same convenience, right? So I want to keep my phone in my pocket. I don't want to have to pull it out, use a gesture, have to be within a certain distance and that type of thing. So I'm a huge fan of the touch technology. But again, when you talk about intent, if I happen to be on the secure side of the door, how do we now all of a sudden negate the individuals that are on the secure side? Well, you'll find with this reader, we have a small antenna with a very small flat antenna that mounts on the inside of the door and negates any signal on the secure side of the door. So now you have convenience, you keep your phone in your pocket. You've got intent by touching the reader, and then you've got security by negating all of the reads that are on the inside of the door, and then unlimited credentials with a small per reader license fee, not a per credential cost. So there are a lot of value propositions when you look at intent, convenience, and security. So just make sure that you look at those as you're dabbling in the Bluetooth technology. Another thing that you'll find is that most Bluetooth readers in the industry are pass-through technology, very similar to what I talked about before. So if I get to it with my phone, it reads my phone, but then it passes through a Wiegand signal to the controller. And so what we've done is we've actually encrypted the Bluetooth communication from the reader and the phone, but also from the reader to the controller. So you've got an encrypted communication, but we can also tell you that it was a Bluetooth read versus a standard credential or card read. Whereas most Bluetooth technology that's out there, again, if you read a credential or read a Bluetooth, you're going to get the same effect out of that because it's just passing that through. But again, to answer this question, as I've went the long way about it, yes, it does have the same wiring that you would on a standard Wiegand reader. As more of these readers become OSDP, you'll see that wiring change up just a little bit, but you're going to see the same wiring to a controller that you would on a standard reader. It has the same wiring. All right. Due to the current situation, are you guys planning to use a no-touch Bluetooth credential? That's a fantastic question. In fact, this is called a touch reader, but really if you get your hand close enough to it without physically touching it, it will activate the reader and authenticate to your phone. So in essence, it is a no-touch reader. You do have to get pretty close because again, we want to know what the intent is of trying to get into that door, and then it can authenticate. So we'll continue to bolster that side of the technology, but the answer is yes. That's very important to know. And if you're utilizing these Bluetooth technology, our Bluetooth technology, you don't have to actually touch the reader. You can get close to it. There is a proximity side to that as well. Apereo only available through PDK. The answer is no. There are other manufacturers of access control that utilize the Apereo line. One thing that's unique about PDK is we are one of the premier integrators into their 16-to-1 network style hub. So if you want to utilize the Apereo technology, you do need to check with the manufacturer of the access control platform and see if they integrate with Apereo. So we've done a very deep integration with Apereo. We've got systems with over 1,000 lock sets and readers on it that are all communicating through Apereo. It's a very unique and gives you a lot of functionality. And again, 3 to 3.5 year battery life on those batteries through and communicating to a 16-to-1 hub. But again, just check with the with ASA Abloy or the manufacturer to see what type of integration they have. Also, Apereo does have what they call a one-to-one hub. So if you just have one reader that you need, communicating to a different access control platform and it needs to be mounted to glass, you can buy their one-to-one hub. In other words, you can use their reader, you take their hub, and instead of it being an IP style hub, now that hub connects to the controller with your data 1, data 0, and all of the other lines, and all it's doing is just communicating the interface between the reader and that hub. But again, it's 1-to-1, not 1-to-16. So if you were adding multiple doors to it and you had 5 doors, you'd have to have 5 hubs, 5 devices connected into 5 ports. If you're utilizing something that's going into their IP stuff, like I've talked about with PDK, now all of a sudden you plug in one hub and it can talk to 16 devices, no controllers are needed. So it's much more cost effective. Can touch be used with all glass walk with a kit? Maybe that's wall, an all glass wall with a kit. The touch reader does have a pigtail coming out of the back of it, so you do have to mount it to a wall or to it. We do have a single gang kit, so it will mount to a single gang box as well, but this does not mount directly to glass. So if you do have an all glass wall, which we've got many of them here, then you just want to mount it to a wall that's adjacent to that glass wall or right next to it, and then you can touch it or get close to it. Last is touch outdoor rated. The answer is yes. So, heat, cool, as well as rain and other weather shouldn't affect this at all. We've had it on the outside of our building for a substantial amount of time, as well as in other applications throughout the country. Very, very robust when you look at outdoor and indoor rated, as well as it's got a really sleek look to it. It's got a little light, like you saw in the video, that lights up. And all of that functionality works indoor and outdoor. Any other questions? Those are fantastic questions. All right, I don't see any other questions. If you have additional questions, always feel free to chat into support@ProdataKey.com or sales@ProdataKey.com. We'll be happy to answer your questions really quick. In many cases, if you just email us and send us your phone number, we're going to call you immediately. For us, it's really about a true partnership, and that's what this free information is about. If you have other individuals that could utilize this, just know that this is all hidden behind our PDK YouTube channel. But if you take that link and share it with other individuals within your organization, they can rewatch this video at any time. Thank you so much. We hope you found value, true value, in Access Control 101 around readers.